Okay. So in this example, we are going to see like a pointer to an array. See, it's a normal integer variable, integer pointer, integer array, and this array of pointers. And now there is a one more concept called a pointer to an array. See, understand the difference. The difference between both of these is just like a circular bracket. Okay. See, in your beginning of the session, we have seen some operators, and in the operators we have seen the operator precedence table. Okay. In the precedence table, here how many operators we have? In this declaration, we have two operators. One is star and another one is this square bracket. Out of this, which is high priority? Star or bracket, square bracket? The bracket is the highest priority. So the bracket indicates what? Bracket indicates that it is array. Correct, right? So this is high priority. So that is nothing but array. And next it indicates that a pointer. So array of pointer. But here also we have like the multiple syntax, which is high priority here. Square bracket, and within the circular bracket we have a star. Now priority will come to the square bracket or the star. Now star is the highest priority one. So the star indicates that like it is a pointer. Next array. Getting right? So this goes like a pointer to array. You can check your like a precedence table again if you forgot. So here the circular bracket will be the highest precedence, then compared with the square bracket. So the priority will be for pointer, and then it will go to the array. Pointer to array. Okay. So that's how like it has come. Pointer to an array. I hope like everybody clear with it. What is array of pointer? What is pointer to an array? See, the name itself it clearly says pointer to an array. So it means this is a one pointer or multiple pointer. It is a single pointer, just like this. See, this P is also pointer, but this pointer is for one integer. For one integer. This pointer is for one integer, but this pointer is for one array, and array size is 5. Very good. That's all. If this is clear, that concept is like we're done with it. See, it's a normal one integer pointer, and it is a pointer to one array. Array size is 5. Now we have a one integer array. The size with like a 5, and it is initialized like this. And here, so let's assume P is a pointer, which is for P how much memory is allocated? 4 bytes is allocated. Let's assume it is 3,000. And for PTR how much memory will be allocated? PTR also it is a 4 bytes. Why? Because it is a normal integer pointer or pointer to an array, or character pointer or double pointer, whatever it is. Already clearly told you, if you are declaring one pointer, for one pointer 4 byte memory will be allocated. If you are declaring multiple pointers like this, here what we are doing, we are declaring multiple pointers, so that for each pointer 4 byte memory is allocated. Okay. So now for this PTR also 4 byte memory is allocated, and then we have an array. So array as usual like a 20 byte of memory is allocated. Now in this P you are assigning the base address. So what will be assigned in P? 5000 will be assigned. And then in PTR you are assigning the address of A. Address of A. Address of A or just A, both are same only. So address of A is what? Again 5000. So this 5000 will be assigned here. See, A is nothing but array. Address of array you are assigning in this pointer. Why? Because this PTR is, what is the purpose? The purpose of the PTR is like it is dedicatedly available to store the address of one array. Please come and sit. Yeah, I've said. So the PTR is purpose is available for to store the address of one array. That is what we are doing. Address of A. A is array. Address of A we are storing in this. Okay. So now you are trying to print. If you are trying to print P, what you will get? P is what? 5000. You will get 5000. PTR? PTR also 5000. Okay. And now you are incrementing P. So if you increment P, what will happen? 5000 will become 5000. No. It is 5004. Why? Because P is what? P is an integer pointer. If you increment, it will jump to next integer. So right now it is pointing this integer. If you increment, it will jump to the next integer. That is, it will become 5004. Okay, that is okay. And PTR if you increment? Yeah, you are almost closer, but make it clear. See, understand, P is what type of pointer? Integer pointer. But PTR is pointer for one array. Okay. If you increment P, it will jump from one integer to next integer. If you increment PTR, it will jump from one array to next array. See, so array size is 5. So from this 5 integer, that entire array, it will jump to next array. But we don't have array, that is our problem. But so what will happen? Now you tell me, like, what will be the change? 5020. It will become 5020 because this PTR is for an like a array of pointer. It is a pointer to array. The array size is 5. So it is jumping from this array to next array. So it is jumping from this 5 integer element to the next 5 integer element. So now if you print this P, you will get 5004 PTR 5020. Please understand the concept clearly. P is like a pointer. The purpose of the P is like it can hold only one integer address. The purpose of the PTR is like it can hold the address of one array. So that's the difference. For P also 4 byte only is allocated. For PTR also only 4 byte allocated. But how it differs? The difference comes when you are doing some arithmetic operation. When you add 1 with the P, it will jump 4, 4, 4, 4 like that. When you add 1 or 2 like that, it will jump as what based on its size. The size is 5, so it will jump as 20 bytes. If size is like 10, it will jump as 40 bytes. Clear? That's all.